Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing straight lines. So I will give you an equation like one of these. You need to turn it into a straight line graph. So let's look at this one here. Now, if the equation you're given is in the form y equals something, then the number in front of x, the coefficient of x is m, which is the gradient, and the number by itself is b, which is the y-intercept. So if I want to graph this line here, first thing I'm going to do is graph the y-intercept where it hits the y-axis down here at 1. So now what I'm going to do is I'm going to use the gradient to find a second point. So remember, the gradient is rise over run. So the top number here tells us the rise, how far we go up or down. The bottom number tells us the run, how far you go to the right. Always go to the right. So because 4 is on the bottom, from this y-intercept, I'm going to go 4 to the right, which is over there. Now, because the rise is -3, I go down 3 instead of up 3. So down 3, I end up here. So now that I have 2 points through which the line passes, I just simply join them up. So let's look at this one here. This is not in the form y equals, so we can't easily read off the gradient and y-intercept. So when it's in this general form ax plus by equals c, it's probably easier to use the X-Y-Intercept method. So you find the x-intercept by letting y equals 0. So if y equals 0, I just get 3x equals 12. And of course, that means x equals 4. So the x-intercept here is 4. Similarly, if you let x equals 0, you get y equals -3. The y-intercept is -3. So all I need to do now is plot the x-intercept here at 4 and the y-intercept at -3 and join them up. So note that both the gradient intercept method and the XY-intercept method are actually doing the same thing. All we're doing is finding 2 points that lie on the line and then joining them up. Now, if you are asked to graph something like y equals 4, if it's just y equals a number, that's a perfectly horizontal line that goes through whatever the number is. So for y equals 4, it has a y-intercept of 4, perfectly horizontal. On the other hand, x equals -3 is a perfectly vertical line, and it goes through x is -3. So that there would be x is -3. So note that lines are always functions unless it's x equals a number. Of course, this yellow line here is not a function because it would fail the vertical line test, but the other 3 are functions. All right, let's look at graphing now a hybrid function. So a hybrid function is when the function you have to graph is basically made up of one or more functions. So let's graph this here. So we want to graph y equals x minus 2, but only for x is less than or equal to 2. So for y equals x minus 2, it would have a y-intercept of -2. Its gradient is 1, so we'd go 1 to the right and up 1. It'd go through that point, and we'd draw a line. But of course, we want the line to stop at x equals 2. So if x equals 2, y is just 2 minus 2, 0. It'd go through there. So the line needs to stop there. So I've put the arrow here. It goes forever in this direction, but it stops here. Now, because we're including that point, because it's x is less than or equal to 2, that's why I've shaded in the circle. Now we want to graph y equals x over 2 for x is greater than 2. So when x equals 2, y would actually be 2 over 2, which is 1. So this would start at the point 2, 1. I'm going to use an open circle because we're not including x equals 2 in this line. So the gradient here is a half. So that means you go 2 to the right. Bottom number is how far you go right. And then top number is how far you go up or down. We'd go up 1. So now we've got 2 points through which this part of the line passes, so I can just draw a line through those 2 points and put an arrow. So, of course, this actually still constitutes a function because it would pass the vertical line test, but it's a discontinuous function. It's discontinuous at x equals 2 because there's a jump there. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.